Hello, I welcome you all in this presentation related to the subject fundamentals of the manufacturing process, and in this presentation I will be talking about the steps related to the casting process. We know that the casting is the fastest way of achieving the final shape as desired using a simplest approach, wherein the molten metal to be used for making the product is used. So, for this purpose there are certain steps which are followed. So, we can say the steps of casting process. This is just, you can say, the brief overview of the casting process. So, the first is the metal which is selected for the casting purpose is first of all melted. So, and this molten metal, when it is melted, to avoid to remove the gases and impurities, the treatment of the metal is of the molten metal is done. So, degassing, fluxing, etc. are the part of the things. This molten metal is filtered. This filtering can be in mold or out of the mold process, just to remove impurities, dross, traces, oxides, etc. And then this molten metal is poured. So, pouring of the molten metal is done in such a way that it the aspiration of the gases is less, as well as the gases present in the mold get enough space or time to escape. So, escaping of the gases from the mold is important to avoid the gaseous defects, and it happens with the minimum turbulence, so that erosion of the mold and interaction with the atmospheric gases is minimum. So, these are the things which are kept in mind while pouring. Then pouring into the mold. So, mold is what? The mold is of the desired size and shape, cavity, in which the molten metal is poured, so that the molten metal takes the shape of the mold, and after this the solidification proceeds. Heat is extracted by the walls of the mold. So, as soon as the temperature reaches to the solidification temperature commencement, solidification begins. So, solidification is normally desired to be of the directional type. Directional solidification is desired, so that all the impurities, gases are automatically starts floating, or they get the passage to escape from the molten metal, and whatever cavity is formed in this case due to the shrinkage of the molten metal, that is filled in effectively by the molten metal from the riser. So, it is preferred that directional solidification is achieved through the proper temperature gradient within the mold. Once the solidification is completed, then we try to ejection of the casting or removal of the casting from the mould. So, depending upon the type of the mould, either ejection may be mechanized or the mould needs to be broken to take out the casting, and after ejection it involves cleaning and inspection of the casting. So, cleaning primarily involves the removal of all fins, extra projections, the gates, risers which have solidified and are still attached with the casting needs to be taken off by cutting or using the sandblasting, tumbling, etc. Different methods are there, and the inspection will help us to see if the castings are having any defect or they are good condition. Based on that they are processed for further steps. So, these are the 4 or 5, 6 major steps related with the casting. Now, how to achieve all this and how these are executed so that the sound casting is achieved, that is what we will be seeing in detail. This was just the overview of the steps related with the casting process. So, here what are the steps? Like this, the melting, and the melting of the metal is realized using the suitable heating system. It may be electric furnace, electric resistance heating based furnace, arc furnace or coal fired furnace. As per the temperature, melting temperature of the metal in process, a suitable heating system is used so that it is brought to the molten state, and once the metal is brought to the molten state and it is treated properly, what we do, this molten metal is brought from the heating system or the furnace near the mould. So, these are the moulds, and in which molten metal is poured. So, here we can see the different the metals in form of the raw material, rods, etc. Is heated so that it is brought to the molten state. Thereafter it is poured into the cavities or mould cavities. So, melting first step, pouring into the mould, and then solidification proceeds, we can see here, and the solidification, thereafter removal of the mould, and then cleaning, finishing and inspection. So, here what we can see, the solidification, of course, it begins from the wall of the moulds and then proceeds towards the center. It is always desired that solidification starts from the remotest place and then it ends at the next to the riser or the region where from the molten metal is being supplied through the in gates. So, that whatever shrinkage is occurring, that can be effectively compensated through the supply of the molten metal. So, this we can see here, this is simply showing the kind of the thermal curve or the cooling curve for the pure metals as well as for the alloys. So, here we can see this is the temperature of the molten metal which is poured into the mould cavity, and then due to the extraction of the heat or transfer of the heat from the molten metal towards the through the mould walls, heat is transferred. So, the temperature of the molten metal gradually decreases until it reaches to the solidification start temperature. So, here at this temperature solidification commences, then it progresses at a constant temperature for pure metals as well as for the eutectic systems, and then once the solidification ends, we can see here the temperature again starts coming down. So, this the first phase is the cooling of the liquid metal, and then solidification, this region corresponds to solidification, and then third region is corresponding to the cooling of the solid. So, basically shrinkage takes place in both the cases. The cooling of the liquid metal, when the shrinkage occurs due to the cooling of the liquid metal, basically this kind of the shrinkage is taken care of by feeding the molten metal from the riser, and the shrinkage of the casting which is occurring in the solid state due to the cooling from the solidification temperature to the room temperature. This kind of shrinkage is taken care of by suitable design of the pattern, by giving the shrinkage allowance to the pattern, so that even after the shrinkage we have the casting of the required size. Schematic, this is as a whole, it shows the different components related with the casting process. Here this is the ladle which is used for transporting the liquid metal from the furnace to the mold location, and then the liquid metal from the ladle is fed into the pouring basin. So, pouring basin is the channel which will be separating, which will be basically acting as a reservoir of the molten metal to feed the same to the mold cavity, and the pouring basin also separates out all the impurities and inclusions, oxides, etc. if they are present in the molten metal. Then from molten metal from the pouring basin is fed to the sprue, and then from the sprue it goes to the runners, and through the runners it enters into the mold cavity. And in the mold cavity, here this is the mold cavity, and there is a riser. Riser is basic, there is a riser, this is the riser and this is the core. So, for making the cavity in the castings, core is used so that this core can be taken off subsequently. So, when the molten metal is filled in, the core presence of the core helps to avoid the filling of the molten metal in this region, and this core is taken out subsequently on the solidification of the casting. And when the solidification in course of the solidification, when there is shrinkage of the molten metal, the shrinking that shrinkage is taken care of by feeding the molten metal from the riser to the casting, and that is how the casting is obtained. This entire arrangement is the mold. It is made of the two portions. One is the cup, and this is the upper portion of the mold, and the drag is the lower portion of the mold. So, these are the different elements or the parts related with the casting process. So, here the mold, you can say mold is the cavity. Just to familiarize the different terms which are related to the casting process. Mold, this is the split mold, and these are you can say this is the mold cavity, and this is through which region through which molten metal will be fed into the cavity, and these are the different types of the molds which are used for making the variety of the products. So, mold is basically cavity of the desired shape and size, always produced with the due allowances for the shrinkage of the solidifying metal, and the later the types means the shrinkage, the later types are generally made of the metals and the graphite, means these molds are made of either the metals or the graphite, and due to the high cost their use is generally restricted to the large production volume. Means if the volume of the casting is limited, volume of the casting which is to be produced, means number of castings to be made is limited, then we use sand molds. If the number of castings to be made are very large, then the metallic molds are used. As a part of the melting, we know that the melting involves the melting of the metal as well as its treatment. So, treatment is basically, the purpose of treatment is to get the right quality and a right quantity of the molten metal which can be fed into the mold cavity, so that the casting of the desired quality can be achieved. Basically, melt treatment involves the fluxing, degassing and alloying for achieving the desired grain structure, so that desired properties can be achieved. So, here if we see, so there are three types of the flux molten metal treatments: fluxing, degassing, and grain refinement oblique modification. So, the fluxes are used to take care of the oxides, nitrites, and the degassing is used to remove the oxygen, hydrogen if these are in the dissolved condition. So, the different compounds are used for the degassing purpose, and the grain refiners and modification, this term is basically used to refine the grain structure, like titanium is used in case of the aluminum alloys, titanium, zirconium, and like vanadium and aluminum is used for the steels. And for the modification purpose, where in certain constituents are refined, like the strontium, sodium in case of the aluminum silicon alloys. So, these are commonly used in the aluminum foundry industry for the grain refinement and the modification purpose. The common the grain refiners which are used is titanium, boron, carbon, and AlTiB. These are the two common types of the grain refiners used in the foundry industry for the melt treatment purpose. The purpose of the melt treatment is providing the molten material with the suitable furnace, so that the molten metal, so this is the scope of the melting, like feeding the molten metal or supplying the molten metal with the proper temperature, so that the desired fluidity is maintained, so that the molten metal gets enough time to fill the mold cavity before the solidification begins, so that it does not lead to the misrun or the lack of filling kind of the defect, or molten metal is fed in the desired quantity, or it is available in the desired quantity for filling the mold cavity, and so that the desired molten metal can be desired molten metal of the required quality can be obtained at the reasonable cost. So, this is the objective of the melting. This is how it is achieved, like the vacuum is applied, and the hydrogen gas is fed. This is the ladle for the treatment purpose. The pouring, as I have said, this is one of the steps related to the casting. Pouring is the pouring technique to be followed helps to introduce the molten metal into the mold cavity, so that the quality castings can be produced, and the purpose is to have the castings which are dense and free from the defect. And how this is achieved? By permitting the escaping of all air and gases present in the mold cavity, or those which are being generated through the mold metal reactions. We know that in case of the sand mold, whenever hot molten metal is fed into the mold cavity, the evaporation of the moisture as well as the interaction between the molten metal and the mold surface leads to the evolution of the gases, and these gases must be removed, otherwise these will lead to the presence of the gaseous defects. And at the same time, it is also expected that when the pouring is done, the pouring is performed with the minimum turbulence for feeding the molten metal, and the pickup of the impurities is minimum when the molten metal is fed and the mold cavity is filled in the minimum possible time, so that the commencement of the solidification begins in the different regions almost at the same time. Large difference in the commencement of the solidification time in the different zones increases the defect formation tendency. We know that the solidification, basically it is desired that directional solidification is achieved in the castings, wherein solidification starts from one end and it completes at another end, so that the defects can be avoided, and the issues related with the shrinkage, such as the shrinkage cavity and the cracks under the excessive restraint conditions, hard crackings are the typical examples which otherwise will be leading to the number of issues. So, in case of the when the directional solidification is not achieved, then these are the issues which are encountered. So, proper solidification means the directional solidification depends on the design of the getting system and the temperature gradient established after pouring of the molten metal. Efforts are always made to locate the riser as well as use the chills if required in such a way that the suitable temperature gradient is established, so that the directional solidification can be achieved, wherein solidification begins at from one end, it completes at another end, and it progresses in one direction. So, all the issues related with the shrinkage and hard cracks can be taken care of. This is where the solidification proceeds. We can see here solidification is starting from the bottom and it is progressing in this direction. These are the dendritic arms which are normally observed in case of the cast components, and if it is not performed properly, then it will lead to have the number of defects and the shrinkage porosity within the casting. After the solidification, the castings need to be removed from the mould, and so depending upon the type of the mould being used, whether it is expendable or non-expendable. In case of the expendable molds, the mould is to be broken to take out the casting, and in non-expendable mould, simply the casting is ejected from the mould cavity. So, this is this diagram typically shows that the sand molds are used for making the mould cavity, and then breaking the mould is involved for taking out the casting from the mould. So, casting is taken out of the mould without any damage, that is one of the purposes. So, ease of the casting removal depends on the type of mould being used. Single use molds, these molds are destroyed after each casting, and there is no major problem, but in case of the multiple use molds, like in metallic molds or die casting processes, the casting need to be ejected properly using the mechanized arrangement. So, removal of the complex shapes poses actually the problem in removal of the casting after the solidification in case of the multiple use molds or where the metallic molds are used. So, once the castings are taken out by breaking the sand molds or the molds which are used for once, or otherwise the castings are ejected through the mechanized arrangement in case of the metallic mold or the permanent mold casting process. Once the casting is available, since whenever the casting is ejected, it has number of undesired features associated with, like the fins, unnecessary projected material, parting line material, the gating molten metal solidified in the gating system and a riser. All these are undesirable parts related to the solidified casting. So, these must be taken care of, and for that purpose only we need to remove all these undesirable parts from the casting, and then remove the unnecessary fins and projections, and for that purpose cleaning is required. So, extra material that remains attached with the casting in the form of the solidified metal at the gate and riser, along with the parting line also metal remains attached with the casting. So, this mold material adhered to the casting of the surface, if the like the sand mold surface fuses with the molten metal due to the poor refractiveness, then that metal also remains attached with the casting and that must be removed and taken care of. So, all these materials should be removed from the finished casting, so that the desired one final casting can be taken can be achieved. And once the casting is cleaned, there are number of methods like the cutting, tumbling, shot blasting etc. are used for the cleaning purpose, and once the casting is cleaned and finished, it is used for the inspection purpose, whether it is sound or not. Like say this is the sprue, and these are the different undesirable parts which are associated with the main casting, which must be removed and taken care of. So, here I will conclude this presentation. In this presentation, I have talked about the major steps related with the casting, and there are 5 major steps like the melting of the molten metal, then pouring of the molten metal, and then the development of the mould cavity, solidification, cleaning, and removal of the unnecessary parts attached with this, followed by the inspection. So, here now I will thank you for your attention.